Ever get that feeling like you just want to dive deep into something? Really understand it, but without all the headaches.
Yeah, totally. Who has the time for all that extra stuff, right?
Well, that's exactly what we do here.
Get to the heart of it. I like that.
Today, we're tackling ancient Indian astronomy.
Ooh, okay.
And let me tell you, this is going to be a wild ride.
I'm ready. Buckle up.
We're talking about civilizations that were figuring out the Earth's rotation, predicting eclipses with incredible accuracy, all centuries before the telescope even existed.
Before the telescope. That's mind-blowing.
It really is.
Yeah.
And the big question, of course, is how did they do it?
Yeah, how?
We'll be digging into the evidence. We're talking old writings, incredible architecture, all to uncover the secrets of these ancient sky watchers.
It's like a plan.
It's not just about what they knew, it's about why it still matters to us today.
Right, the impact.
Exactly.
Okay, I'm hooked. Where do we start?
Well, we got to start with a true pioneer, a 5th century scholar named Aryabhata. This guy was brilliant.
5th century, okay.
At just 23 years old, he wrote this incredibly influential work called the Aryabhatiya.
23, wow. Okay, the Aryabhatiya.
And one of his most groundbreaking contributions.
Hit me with it.
He figured out that the Earth rotates on its axis.
Hold on, so he's debunking the whole, everything revolves around the Earth idea way back then.
Exactly. He basically said, nope, the Earth is the one moving. He even wrote, the starry sphere is stationary, and the Earth moving makes it appear to move.
Whoa, hold on. That's centuries before Galileo, right?
Centuries.
And he's just casually dropping this knowledge.
Just like that.
That is some serious forward thinking.
Yeah, way ahead of his time.
I mean, to come up with that just from observing the sky, that's remarkable.
He didn't stop there, though. He also calculated the length of a year.
The length of a year, okay, and he got it right.
Pretty much. He calculated as 365.258 days.
That sounds about right.
The actual length. 365.258 days.
So he's off by, 2/2 of a day?
16 minutes.
16 minutes. Are you kidding?
Nope. Just think about the precision, the dedication to observation that took.
It's incredible. No fancy telescopes, no computers. And he's getting that level of accuracy.
And remember, this is just the beginning. His understanding of the solar system, it was way ahead of its time, too.
Okay, you got to tell me more. What else did he figure out?
Well, for starters, he proposed that the planets move in elliptical orbits.
Wait a minute. Isn't that Kepler's thing? The laws of planetary motion?
Kepler gets the credit, but Aryabhata was writing about this over 1,000 years earlier.
Over 1,000 years earlier. Come on, that's got to be some kind of record.
And the accuracy doesn't stop there. He also calculated the moon's diameter.
Oh, wow. So he's figuring out the size of the moon now.
He calculated it to be about 3,300 kilometers.
Not sure how big that is off the top of my head.
The actual diameter is around 3,474 kilometers.
So he was pretty darn close.
He was just a few percentage points off.
That's nuts. Just looking at the moon and figuring that out. How is that even possible?
It really speaks to the ingenuity and mathematical skills of these ancient astronomers.
Right. It's not just guesswork. It's serious science.
And speaking of science, he even figured out lunar eclipses.
Lunar eclipses. No monsters eating the moon.
Nope. He correctly explained that a lunar eclipse happens when the Earth passes between the sun and the moon.
So basic geometry, but applied to the cosmos. Pretty cool.
He laid it out in purely scientific terms.
That's a huge step, moving away from myths and superstition.
It is.
I'm really starting to see how influential this guy was.
He was a true pioneer. But it wasn't just him, There are other important writings from around the same time, like the Surya Siddhanta.
Okay, so Aryabhata wasn't alone in all this.
Not at all. The Surya Siddhanta, which probably took its final form sometime in the 4th century CE, was basically an astronomy handbook.
A handbook?
It was packed with information on how to calculate planetary motions, predict eclipses with crazy accuracy, even estimate the distances to stars.
Like a textbook for astronomers back then.
Exactly.
That's amazing. And all this while, in Europe, people were still arguing about whether the Earth was flat.
Crazy, right? It really challenges our perspective on the history of science.
Big time. We're so used to thinking of scientific progress as this straight line from Greece to Rome to the Renaissance. But there were clearly other cultures making huge strides at the same time.
Absolutely. And to see that in action, let's fast forward a few centuries to something you can actually visit today. Jantar Mantar.
Jantar Mantar, what's that?
Have you ever seen pictures of these giant, kind of abstract-looking structures made of stone?
Maybe. Are those the things that look like sundials on steroids?
That's them. Those are astronomical observatories built by Maharaja Jai Singh II in the 18th century. The most famous ones are in Jaipur and Delhi.
Astronomical observatories made of stone.
Yep. They're like these massive, intricate sculptures, but every curve, every angle is designed for precise astronomical measurement.
Okay, stone structures that can measure the stars. I need details. How accurate are we talking?
Let's take the Samrat Yantra, the giant sundial in Jaipur.
The biggest one.
That one can measure time to an accuracy of 2 seconds.
2 seconds. That's like an atomic clock.
Imagine that level of precision coming from a structure built entirely out of stone.
My mind is blown.
And that's just one instrument. They had others like the Ramayantra, which was used to track the positions of stars and planets.
So they weren't just for show. These were actual working observatories.
Oh, yeah. Maharaja Jai Singh II was a serious astronomer. He built these to create accurate calendars, predict eclipses, even help with navigation.
Wow, so they were actually using this knowledge for practical purposes.
Absolutely.
That makes so much sense. And it's just wild to think that NASA actually studied Jantar Mantar in the 20th century.
Right, like ancient knowledge informing modern science. That's pretty awesome.
It shows you just how ahead of the curve they were. I mean, their work is still relevant centuries later.
Okay, so let's talk about something that clearly fascinated these ancient astronomers. Eclipses. It seems like they went from spooky explanations to actual scientific understanding pretty early on.
Yeah, it's interesting how our understanding of the natural world evolves, right?
For sure. And even in their oldest texts, like the Rig Veda, there are mentions of eclipses, like one that's estimated to have happened around 3000 BCE.
Whoa, 3000 BCE. That's going way back.
That's 5,000 years ago. And centuries later, you have astronomers like Varahamihira in the 6th century making detailed eclipse predictions in his book, the Brihat Samhita.
Oh, wow. So they weren't just observing them anymore. They were figuring out when they would happen.
Yep. Varahamihira was laying out the timing, the duration, everything with a level of detail that's just incredible.
That's serious math and astronomy skills right there.
And of course, they had the right explanation. The moon blocking the sun, the Earth's shadow on the moon.
No more myths or legends, just straight up science.
It's remarkable. They even developed ways to time these eclipses pretty accurately using water clocks.
Water clocks. That's clever.
And being able to measure time was crucial.
Yeah, you got to know when things are going to happen if you're going to predict them, right?
Exactly. And this ties into the Hindu calendar and why a lot of Indian festivals, like Diwali, have dates that seem to change every year.
So it's all connected to the stars.
It is. The Indian calendar systems are lunisolar, meaning they combine the cycles of both the moon and the sun.
Okay, lunisolar.
So predicting eclipses and other celestial events, absolutely vital for keeping those calendars accurate.
It all makes sense now. So what about the stars themselves? Did ancient Indian astronomers have their own system for, mapping the night sky?
They did. They had something called nakshatras.
Nakshatra, okay. Tell me everything.
Imagine dividing the sky into 27 segments, kind of like a celestial map.
27 segments. Okay, I'm picturing it.
Each segment is a nakshatra.
So like constellations.
Sort of, but they're more like markers along the path the sun seems to take across the sky.
Okay, I see. And this is an old system, right?
Very old. We see them mentioned in texts like the Taittiriya Samhita, which is from around 1200 BCE.
1200 BCE. They were already mapping the stars back then.
Yep. And the nakshatras weren't just for mapping. They were used for navigation, timekeeping, even agriculture.
So they were really woven into their daily lives.
Absolutely.
Okay, so how does this all connect to the zodiac signs we know today? Like Aries, Tauruses, all that.
Well, there's a connection there for sure. The Indian system, called Rashi, which has 12 signs, it's likely connected to the Western zodiac through ancient trade and cultural exchange.
So ideas about the stars were traveling across the world, even back then.
Yeah. And we see this blend of astronomy and astrology in Varahamihira's Brihat Jataka, a text that's still consulted for horoscopes today.
Right, so the scientific and the mystical kind of intertwined.
And it's not just in the text, it's in the architecture too.
Yeah.
Get this, some ancient Indian temples were actually designed as astronomical instruments.
Yeah, what? Temples that double as observatories.
I got it.
That's so cool.
Take the Konark Sun Temple in Odisha. It was built in the 13th century, and its giant chariot wheels, they actually work as sundials.
No way. So they built an entire temple to track the sun's movements.
And it gets even more amazing. During the spring and autumn equinoxes, sunlight lines up perfectly with certain points inside the temple.
That's incredible. Like,
Oh,
did they plan that?
Oh, yeah, it was intentional. The Chatubush Temple in Madhya Pradesh is another great example. Its pillars are aligned to the sun's positions during the solstices.
The solstices.
Yep, the longest and shortest days of the year. It's like they built these temples as these cosmic labs, blending their faith with their scientific understanding.
It's amazing how they wove together those different ways of seeing the world.
It really makes you wonder what other secrets are hidden within these ancient structures.
Like, are we just scratching the surface of what they knew?
It's definitely possible. So as we wrap this up, what are the key takeaways about ancient Indian astronomy that you think our listeners should remember?
Well, first off, just their sheer desire to understand our place in the universe. That's powerful.
Sure.
And then the incredible discoveries they made. Aryabhata figuring out Earth's rotation, the amazing precision of those Jantar Mantar instruments, their eclipse predictions, even temples as observatories. It's just mind-blowing.
And don't forget, they were doing all of this through observation, logic, and mathematics. This wasn't just guesswork or mystical thinking. This was science.
Absolutely. It really challenges us to rethink our assumptions about the history of science and acknowledge the incredible contributions of cultures beyond the traditional Western narrative.
It's a reminder that brilliant minds have been exploring the cosmos for centuries all over the world.
Exactly.
It makes you wonder, with all the incredible things they figured out without any of the technology we have today, what else might be out there waiting to be rediscovered?
Lost knowledge, hidden insights. Who knows what's still out there?
It's exciting and humbling at the same time.
Totally.
Well, that's all the time we have for today.
Wow, that was a deep dive.
It was. Thanks for joining us on this incredible journey through ancient Indian astronomy. Until next time.